please don't adjust your monitors. Our launch site really is that beautiful. Since we have a little more time before liftoff, we can share some more information about the other payloads on board It's Business Time. The Cicero 10 spacecraft from GeoOptics, manifested by Tyvak, brings another commercial weather satellite onto Electron. Joining Cicero is the Irvine 01 spacecraft, built by a collection of high school students from 6 different schools in Irvine, California. This is the first in a series of CubeSats from the Irvine CubeSat STEM program, which gives students first-hand experience in spacecraft design, operation, construction, and exposure to payloads. The students in the program prepared a video to tell us more about Irvine 01's mission.
When I first found out that we were going to send something in space, I couldn't believe it. And here we are about to do something big that I've never seen before in any high school.
CubeSat is a type of miniature satellite that's used typically for space research.
What happens is it goes in with a larger project
And detached at a certain point, and it'll go on its own orbit.
Be able to go ahead and work towards a common goal of having a successful flight, I think is just really unique for our district, and our students are ready. You know, they're ready to go ahead and take on something like this.
This will put Irvine on the map globally. We will be a very important program moving forward for all eyes to watch.
We also had a last-minute addition to the It's Business Time manifest. Australian company Fleet Space Technologies have 2 Proxima satellites on board. These spacecraft will form the foundation of a global Internet of Things communications constellation to provide internet connectivity for millions of sensor devices in remote locations across the planet. Applications for Fleet's tech are almost endless and range from precision agriculture and virtual fences to maritime logistics and mining. What's particularly exciting about these spacecraft is the speed at which they were manifested. They joined Electron in record time, with payload licensing and full integration complete in just 2 months. Now the final payload on It's Business Time is the Nabeo dragsail from HPS of Munich, Germany. The Nabeo is designed to help passively deorbit satellites at their end of life by increasing the amount of drag the spacecraft experiences. This lowers the spacecraft's altitude and drags it back into the Earth's atmosphere, where it burns up on re-entry. Innovations like this will play a significant role in reducing space junk in low Earth orbit. For today's mission, Nabeo will be hosted on the kick stage but will not separate from the vehicle. The count continues to proceed and currently remains go for launch.
Stand by, LC. LC FTS mission code.
Yes,
I can confirm that FTS is green and go for launch.
thank you. And to all operators, there should be no red
While
flag
the
when you launch
Electron,
from
which you see
rotation.
on the launch pad, is launched in New Zealand, the majority of the vehicle, including the engines and avionics, are produced in Huntington Beach, California, in the United States. The 3D printed Rutherford engines start their life in sunny California,
Flight
where they are
RCR
assembled and then
Go.
shipped to New Zealand for
Range is
testing
green,
and
RC
integration
conduct.
into the vehicle.
Copy range.
Final assembly and testing of vehicle components occurs here in Auckland. When completed, the Electron makes its way by road to the Mahia Peninsula and Launch Complex 1.
Your status.
Our launch site at LC-1 was designed by
Flight
Rocket
safety
Lab
green.
and is the only privately operated FAA-licensed commercial launch range. Next year, Rocket Lab will begin launching from its second Launch Complex 2, currently being constructed at the Mid-Atlantic Regional Spaceport at NASA Wallops on the east coast of the United States. Let's turn over to our control center audio and
Flight
follow the
LCR
remainder
mission
of the
code.
count.
Go.
Vehicle is ready.
Copy. Vehicle is ready. VMS, this is flight on mission cord.
Go flight.
Roger. We are go for auto sequence start at T-minus 2 minutes.
Copy. Locking auto sequence.
Three minutes and counting.
Avionics LC on mission code, please confirm all ALV bats have been switched to internal power.
Vehicles on internal power.
And RCO confirm ground power has been disabled on all 3 stages.
I can confirm ground power is dropped on all stages.
To all operators, vehicle is on internal power.
Pressing locks. Pressing Kiro.
PLS, please disable anti-geysering and confirm.
Anti-geysering is disabled.
Stage 1, confirm that stage 1 is pressed.
Stage 1 pressed.
Stage 2, confirm stage 2 is pressed.
Stage 2 is pressed. Fast barge active. Deluge turning on. Pumps on, deluge running. Setting GNC states. Re-readying engines. Flight mode.
10, 9, 8, 7, 6, 5, 4,
Ignition.
3, 2, 1.
Vehicle.
In stage 1.
IIP traffic downrange.
Dynamic pressure 50% of maximum.
T plus 1 minute, flight is nominal.
Coming up on maximum dynamic pressure. Max dynamic pressure.
Stage 1 propulsion still nominal.
Altitude 20 kilometers. Guidance is nominal.
Dynamic pressure has fallen to 50% of maximum.
Power pack CO2-1.
AOS at Chatham's station.
Minimize AOA. Entering mode, burnout detect.
Time to go 8 seconds. 5 seconds. 2 seconds.
Stage 1
Shutdown.
Miko.
Separating.
Stage 2 engine started. Propulsion nominal. Vehicle is stable.
Separating fairing.
Fairing separation.
Speed 2.5 kilometers per second.
IB continuing to follow nominal track.
Flight remains nominal.
Stage 2 propulsion remains nominal.
Coming up on 3 kilometers per second.
Altitude is 200 kilometers. Hot swapping. Eject.
Stage 2 propulsion still nominal.
The Electron is unique in that its Rutherford engines are driven by high-performance, brushless DC electric motors and lithium polymer batteries. What you saw a few moments ago was the ejection of 2 of our 3 battery packs from the second stage. This is done to increase performance
Time
by
to go,
reducing the
approximately
amount of
100
spent
seconds.
mass that's carried to orbit.
Flight
Yes,
failsafe
failsafe
is
down.
disabled.
Flight copies.
60 seconds. Switching stage 2 to mode burnout detect. "20 seconds remaining.
Engine shut down.
Transfer orbit looks nominal.
And that successfully completes the first half of our flight with a successful orbit injection. Electron's kick stage has separated from stage 2 and is now coasting as planned. The Electron kick stage makes up the final stage of the launch vehicle and provides
vehicle is
Electron
orbital.
the capability to precisely inject customer payloads into their final designated orbit, as this graphic explains.
Range copies, IP lifted.
While stage 2 reaches an initial parking orbit, as shown here, the kick stage completes the mission. First, the kick stage is separated from Electron and then performs a 42-minute coast. At 51 minutes into the flight, the kick stage will be ignited and will circularize the orbit, at which point all of our customer payloads will be deployed. As good stewards of the space environment, our kick stage design is such that the Curie engine can perform a deorbit maneuver to enable it to re-enter the Earth's atmosphere faster and burn up, therefore reducing space debris. As the kick stage enters its coast phase, we're going to transition over to our tracking graphic, which will show the location of the kick stage as it coasts over the Earth. We are currently southeast of New Zealand with the clock, and when the clock reaches T+ 45 minutes, we'll return with commentary coverage of payload deployment. If you've been staying up late to join us, now might be a good time for a power nap. If you're planning on staying awake, enjoy these sweet tunes from Tim Dodd, the Everyday Astronaut.